So now, in this particular question, we are supposed to explain with examples exactly what is meant by the term mole. Apart from that, we are also going to give you the formula to determine the number of moles present in a particular substance. Now, we have a huge amount of information coming your way so that I can properly explain to you what exactly a mole is. Let's begin. Now understand, we know that the atomic mass of a particular element has been given to us. For example, if I have carbon, its atomic mass is 12. But if I have 12 grams of carbon, I have 1 mole of carbon. In a similar manner, the atomic mass of sodium is 23. If I take 23 grams of sodium, then I have 1 mole of sodium. And finally, you guessed it right, if I take calcium, the atomic mass of calcium is 40. If I take 40 grams of calcium, then I have 1 mole of calcium. Now this is something which is valid for atoms, which is valid for elements, but I can also do it for elemental molecules. Now in this particular case, say suppose I have diatomic hydrogen. A single atom of hydrogen has a mass of 1. Two atoms of hydrogen which are present together will have a mass of 2. So if I have to take 2 grams of hydrogen, I will have 1 mole of hydrogen. In a similar manner, the atomic mass of nitrogen is 14. But 2 atoms of nitrogen are present together in a molecule of nitrogen. So 14 into 2 is 28. If I have 28 grams of nitrogen, I will be getting 1 mole of nitrogen. In a similar manner. And finally, I know that the atomic mass of oxygen, and this is the one that I want you all to pay special attention to, is 16. But I have 2 atoms of oxygen combined together to give you a single molecule of oxygen. So 16 into 2 is 32. If I have 32 grams of oxygen, I have 1 mole of oxygen. Finally, to finish it off, to top it off, we have molecules which are in the form of compounds. The first one is water, given in the formula H2O. What is the mass of an atom of hydrogen? 1. How many do we have? 2. So 1 into 2. What is the mass of an atom of oxygen? 16. How many do we have? 1. So 16 into 1. Now that is 2 plus 16 gives me 18. If I have 18 grams of water, I have 1 mole of water. If I want to do this for carbon dioxide, formula CO2, mass of an atom of carbon, 1. In this particular case, mass of an atom of carbon is 12. How many do I have? 1. So 12 into 1 is 12. In a similar manner, I have oxygen. How many atoms? 2. Mass of an atom of oxygen, 16. 16 into 2, 32. So 12 plus 32 is 44. If I take 44 grams of carbon dioxide, I have 1 mole of carbon dioxide. And to finish it off, to top it off, I have nitric acid. Given the formula HNO3. 1 atom of hydrogen into 1. 1 atom of nitrogen into 14. 3 atoms of oxygen into 16. So there we have it. 1 plus 14 plus 48 gives me 63. If I have 63 grams of nitric acid, I have 1 mole of nitric acid. So what have I understood by all of these statements over here? Very simple. 1 mole of a particular compound is the mass of that substance in grams, equivalent to the magnitude of its molecular mass. And what is the SI unit of this? The SI unit is obviously mole, which is MOL. Let's write down the answer. Let's begin. So a mole is that quantity of a substance whose mass in grams is equal in magnitude to the molecular mass of that particular substance. It is calculated in daltons. We know as a matter of fact that if I have the atomic mass of oxygen, it is 16 daltons. The molecular mass of oxygen is going to be 16 into 2, which is 32 daltons, because oxygen is diatomic. Now what do I need to do? I don't need to take daltons of oxygen. I need to take grams of oxygen. How many? 32. So 32 grams of oxygen is exactly 1 mole of oxygen. To finish it off, I can say that the formula to determine the number of moles is given as follows. What am I going to do? I'm going to take a simple numerical value. Number of moles of a particular substance are given by the formula N, or are represented by the formula N. I will have two values, one numerator, one denominator. Who do I have in the numerator? Let's have a look. I am going to have mass of a particular substance in grams. That will be given in the sum, divided by the molecular mass of that particular substance. Now when I do this, when I calculate this, I will be getting the number of moles of a particular substance.